Welcome everybody. So today we're going to be doing our week 2, day 2 DMD questions, and it's going to be based on divisibility. And I'm going to let you all know first that for today's content is going to be a little bit long. So our first part we're going to be tackling is going to be on the based on tail end numbers. So while we're talking about, we're going to be looking at our last few digits. The second method of a divisibility will be using the sum of the digits. And last but not least, the difference of the group of numbers, okay, based on your 10 to the power n plus 1. So we have a few types of methods over here, and we're going to be focusing on these three main types over here, because as long as we know these three main types, we can actually decompose a lot of various methods of divisibility. So we tackle on your based on tail end numbers first. And what do I mean over here? I'm talking about 10, 100, 1000. Because as long as you can see over here, the moment a number is divisible by 10, we know that it's also going to be divisible by 2 and 5. If it's divisible by 100, it is also divisible by 4 and 25, and so on and so forth as well. So we can see the main three examples. And let me just decompose a number for you very quickly so that we can see these three examples. So A, B, C, D, E, F. I can break it down to actually 10 multiplied by A, B, C, D, E, and after that, I plus a F at the back. If you notice, 10 is definitely divisible by both 2 and 5. So if I want to check if a number is both divisible by 2 or 5, I can just look at the last number. And in fact, that's what we were also taught of when we know the basics of divisibilities of 2 and 5. What about 4 and 25? So the same thing applies as well, but now we are focused on a little bit more numbers. 100 multiplied by A, B, C, D. And look at this. I'm isolating the last two digits, E, F. EF over here, basically it's your last two digits. The moment we know that the last two digits is divisible by 4 and 25, we know that this whole number is going to be divisible by 4 and 25. Since we know 100 is already divisible by 4 or 25. The same goes for 1000. The logic basically is the same. Now we're just focusing on the last three digits. Okay, so let's go over to our sum of digits. What about 9, 99, and 999? So 9, basically, we have our origin of the numbers 3 and 9. Okay, the numbers 99 basically can also help us with the calculation of 11. Although I would actually not really recommend so much on looking at this value, but we are going to be focusing on the numbers. The methods we're going to be focusing on later on is going to be the third style for 11. What about 999? We can actually use it for the numbers 27 and 37 as well. So let's look at 9 first. And how do I know that this number is definitely going to be divisible by 9? We can actually break them down into a much smaller group of numbers over here. Let's say I write it out in this manner here. A is in the 100,000 position, so it's 100,000 A. B in the 10,000 position, we have 10,000 B. Then after that, followed by 1,000 C, followed by 100 D, followed by 10 E, followed by F. But each of these numbers over here can actually be broken down into 99999A plus A plus 9999B plus B plus 999C plus C plus 99D plus D plus 9E plus E and plus F. But why am I focusing on breaking numbers into this manner here? Do you notice that each of these sets of numbers, 99999, 9999, 999, 999, these are all divisible by 9 or 3 already in this case. So we don't even need to look at these numbers. We only need to look at the remaining digits, A, B, C, D, E, and F. So let me try to regroup for you so it's going to be much easier to see. Okay, we're not going to be focusing on the one in red. 99999A plus 9999B plus 999C plus 99D plus 9E plus, okay, sorry, just end over there. Okay, we're not actually focusing on these numbers because we already know they are divisible by 9 or 3. Instead, what we're going to be looking at is actually the remaining numbers at the back. A, B, C, D, E, F. The moment we check the sum of our digits, the 6 digits over here, we can straight away actually tell that this number will be divisible by 3 or 9. So that's why you see here, we talk about the sum of digits. And can I even apply it for the digits 99 and even 999 as well? So if we go to another example for 99, and I'll just decompose it for you rather quickly. What we can do here is just simply 1000. Okay, 1000 multiplied by AB. Then after that, we have 10 multiplied by CD. Sorry, 10,000 multiplied by AB. Then after that, 100 multiplied by CD plus EF. From here, we would get 9999 AB. Sorry, 9999 times AB. Okay, so it's going to be a bit easier for you all to see. Plus 99 times CD. And we group them together. And we take the other numbers out. Again, we are going to get these numbers. AB, CD, EF. So once again, check the numbers at the back. If they're divisible by 99, then we know that the whole number is going to be divisible by 99. And the last one, for 999. Same thing, we decompose the values once more. We're going to get your your 1000 multiplied by 1000 multiplied by A, B, C. And we're going to have your D, E, F. And it's going to split into 999 ABC. And we're going to be adding separately your values of A, B, C plus D, E, F. Sorry, let me make a small change. This plus will be outside. So the moment we check the last part over here, the sum of the 3 digits, ABC plus DEF, then we can already tell that this number over here will be divisible by 999. And since we know it's going to be divisible by 999, we can even use these values over here to go and check if it's divisible by both 27 and your 37 as well. So not just 999, it actually helps in your 27 and 37 as well. So one last thing to take note for all these 3 parts when we are doing the sum of digits is actually how to go and look at your splitting of the numbers. For multiples of 9, we are going to be splitting all of them into your single individual numbers. For your multiples of 99, we are going to be splitting into 2 numbers, every 2 numbers. And for multiples of 999, we are going to be splitting into multiples of 3 numbers. So this splitting over here will be particularly important, especially when we tackle our difference of your group numbers as well. So let's look at multiples of 11, 101, and 1001. So once again, these numbers can be split as such. 11 helps for, of course, 11, 101 helping for 101. 1001 actually doesn't just help for the number itself, it also helps the numbers 7, 11, and 13. Because as we know, 1001 is basically 7 times 11 times 13. If we can find that a number is divisible by 1001, it will help for all 3 of these methods. But if you're asking for the multiples of, if it's a number is divisible by 7, 11, or 13, we can actually use the same method over here for 1001. So let's start to go and tackle, starting from 11. Once again, I'm going to use your fraction decomposition to go and explain to you. So this is going to give us this. 100,000 A, 10,000 B, 1,000 C, 100 D, 10 E, and F as well. So these numbers basically decompose in the same way as for what we did from earlier on, but I'm going to make a slight change instead. And I'm going to show you now 99999. Sorry, over here is going to give us 100,001 A minus A to balance out my first term. 9999b plus b for my second term, 1001 c minus c for my third term. Then after that, we have 99d plus d for my fourth term. I have 11e minus e for my fifth term, and I have f. And why do I want to split it in such a weird method over here? Similar explanation. If you look at these numbers over here, they are all going to be divisible by 11. So all we need to do now, is actually to look at the remaining digits here, and it's going to give us this. Okay, 10001 A plus 9999B plus 1001 C plus 99D plus 11E. And we're going to be splitting the other numbers behind, and in a specific manner as well. If you look at these are plus B plus D plus F plus B plus D plus F, but we are subtracting away a few numbers. Minus A, minus C, minus E. Since we're subtracting all of them away, we can subtract the sum of them too. A plus C plus E. And if you look at this entire section at the back, the moment we can tell that these numbers over here, B plus D plus F minus A plus C plus E, it immediately gives us the number that is going to be divisible by 11. So take note, it can be either B plus D plus F minus A plus C plus E, or it can be A plus C plus E minus B plus D plus F, whichever gives us a positive number. The same idea can be then applied into our later values as well. So, namely, your multiples of 101. This time round, rather than splitting into your individual digits, similar to what we did for 99, we're going to be splitting into 2 digits over here, every 2 digits. And now, once again, please take note at how I do the fraction decomposition. It's going to give us 1000 times AB plus 10,000 times AB plus 100 times CD plus EF. And again, this can then be later broken down into 10001, okay, times AB, okay. And after that, this will be, I made a small mistake again. This is 9999 times AB plus 101 times CD. Then after that, your EF. But again, the values will then be added with the values at the back. We have your AB to balance out the front. Then after that, we need to minus a CD, and we need to add a EF again to balance as well. And if let's say I were to rearrange these numbers, once again, what do we see? Okay, 9999 times AB plus 101 times CD. But if we look at the numbers at the back, we focus on summing every alternate pairs of numbers. So we're going to add AB plus EF, but then we are subtracting CD. So we see here, EF plus AB, then we are subtracting away just this CD alone. If there are even more numbers, let's say we give you a few more examples. 1, 2, 3, 4, 5, 6. And I were to split my terms into even more numbers. Same thing, we do the alternating pairs here. So EF plus AB, and with these numbers at the 3 and 4, we add them together. This minus over here will apply for CD, the 56, this 12 over here. So basically, we are subtracting away all these values as well. So that's why we need to understand. For this method here, we are alternating between every 2 numbers. For 1001, same thing, very similar. We are splitting it into 3 values. Again, using fraction decomposition, the place value decomposition is going to make it a lot easier. So it's going to give us 1, 0, 0, 0 multiplied by A, B, C. Then after that, we plus D, E, F. And instead, we're going to split it like this. 1, 0, 0, 0, 1 times A, B, C. Then after that, we are going to be separating the two numbers again. We're going to get D, E, F minus A, B, C. So again, this time every 3 numbers. So even if we have more numbers again, 1, 2, 3, 4, 5, 6, same thing. Add these two pairs together, then we are going to be subtracting these two pairs together, or the other way around, whichever actually gives you a positive value. And take note again, this 1001 can also help us in the calculations of 7, 11, and 13. But of course, we already learned that 11 can be used we can actually use the earlier method, okay, by splitting into your individual digits to do the calculations. So I'll tell you, it's typically used for your 7 and 13, and in cases like bigger numbers, 1001 as well. So you have learned the methods over here. Let us apply a quick one to this question. Now, on an electronic clock, okay, the date is always displayed as an 8-digit number in your year, month, day format. For example, January 1, 2001 is displayed as 2001, 0101. Now, if the last day of 2001 is a number that is divisible by 101 and it's represented by 2001 ABCD, we want to find the values of ABCD. And if we think about it, last digit of 2001, I'm pretty sure that it is very likely to actually appear at the closer end of the year. Maybe even trying to say that the months should automatically be thought as 12. I mean, this is a possible case, but we need to go and verify it again later. Now, let's look at the numbers. If we're talking about 101, do you remember what we did earlier on to do our place value decomposition? We cut our values into pairs. And remember, we're going to be summing our pairs together, 11 and CD. Then after that, we're going to be subtracting 20 and AB. Or if we want, we can even do it the other way around as well. Because if we notice, 20 is going to be bigger than 11. Since we do not know AB and CD yet, okay, we probably need to go and use, we can take 20 as the bigger number instead. So we can take 20 plus AB. Remember the line at the top is representing a 2-digit number. Then we are subtracting away from the sum of your 11 plus CD. This means that we are going to get 20 plus AB, okay, minus 11. Then after that, we minus CD as well. Or basically 9 plus AB minus CD. So this number over here has to be a number that is divisible by 101 as well. And if this is going to be a number divisible by 101, this means that this has to be either, let's say, 9 plus AB plus CD, either has to be maybe 101, maybe 202, maybe even the number 0. Okay, the number 0. So actually, we can actually consider using 0 as well, because technically a number 0 is actually kind of divisible by all other numbers, since in this case, it will leave you a remainder of 0 anyways. So why not we instead write it in this manner over here? You write that AB minus CD actually gives us the value of 0, which means that your CD minus AB has to be a difference of 9. So if let's say we want to place your month as 12, right, which is your AB, and I take AB as 12, this means your CD must be 12 plus 9, giving us 21. This number actually makes sense because we can have the 21st of December. So our value for ABCD will be 1, 2, followed by 2, 1. And just like that, we have finished our final part for this explanation. So once again, for your DMD, please remember to go ahead and complete the 3 questions that are being sent out, to send your answers inside the group chat, and also please take note to go and look out for the solutions that will be sent out on the next day. And that's all we have for today.